Do you have friends? Cause I don't. And that's why I decided to add AI bots to my multiplayer game. That way I can play anytime I want, no friends needed. By the way, if you're new here, I'm xzippyzachx, and I'm making a multiplayer first-person action shooter game with a variety of different game modes. If this sounds like a game you're interested in, go wishlist X mode now on Steam. AI, or NPCs in video games, are either awesome and can make the game feel really immersive, or they're too dumb and break your immersion from the game completely. This is why AI can be very difficult to implement in video games. With X mode, I wanted to ensure that AI bots are actually fun to play against, so that even if the lobby is not full of real players, you can still enjoy playing the game. I also kinda just wanted to make myself some friends, but yeah. So the plan was simple: make bots that act as close as possible to real players. Spoiler alert, that's hard to do. The first thing I needed to figure out is how the bots would actually be controlled and how they synchronize over the network. I came up with a smart way of handling this problem that would limit the amount of work I would have to do. Right now, the player clients send their inputs to the server as an array of booleans. Each element of the array represents a key input as either pressed, true, or unpressed, false. Let's call this array the inputs. For a real player, the input values are set by the buttons of your keyboard/mouse or controller. If the forward element is true, then move the player forward. If the jump element is true, then make the player jump. And all this control logic is already networked by sending these inputs over the internet from the clients to the server. Then the movement code uses these inputs to know how to move the player. Now, here comes my approach to basically reuse what I've already implemented for controlling players by also using it for the bots. Essentially, what I've done is created a decision-making system where the bots decide what the values of the input should be, and this is all done on the server. I'll talk about how they decide in a second, but this way I didn't have to write any new networking code related to bot controls. I could just reuse the existing stuff. So now I needed the bots to actually know what inputs to set in order to control themselves. For this, I created a finite state machine, which is essentially the decision-making component of the bot. A finite state machine is a set of states and rules to change between these states depending on the situation the bot is in. For example, a bot could have an idle state, and it could change to a combat state if an enemy is in its proximity. When the enemy is no longer in proximity, it can change back to the idle state. Or while in the idle state after a random amount of time, the bot could change to a patrol state. Using object-oriented principles like inheritance, polymorphism, and the state design pattern, each one of these states contains the logic required for the bot to behave how it should in that given state. For example, the patrol state has the bot move to a random position on the map. But how does the bot know how to get to that position and how to avoid all the obstacles in its way? For this, I used the Unity nav mesh system, but rather than using the regular Unity nav mesh agent, I basically wrote my own that uses the path generated by the nav mesh to decide what inputs to set to control the bot. Using the Unity nav mesh system, I generate a path between the bot and a random point on the map. Then using this path, the bot rotates towards the next point in the path and moves forward until the point is reached. This is then repeated for all the points in the path until the end of the path is reached. If we look in the lobby, now you can vote to fill the empty player slots with bots. If more real players join mid-game, a bot will be replaced by them. Or if a player leaves, they will be replaced by a bot. Okay, that's enough talk about how AI bots work. Basically, they kinda act like real players. And they're actually kinda hard to play against, which is good because that makes it challenging and fun. So to test out the new bots, I thought it would be a good idea to do a bot Battle Royale. Alright, here we go. It's gonna be real hectic at the beginning here. Lots of fighting going on. xzippyzachx takes out Tito, Mr. Loney takes out the Wired Spider, Tornado takes out Alex Rock, Rug takes out xzippyzachx, Crichton takes out Play. Let's zoom in here. Zippy with the sniper, Starsift with the UMP. Oh, Starsift takes out somebody else. He's coming back for Zippy. He takes him out. Who do we got over here? We got Tom. Tom takes out Lucky. Tornadoes jumps down on him. Tom takes him out. Who do we got left here? We got Tom in the center. We got RDP over here in the shooting range, and we got Starsift by the stairs. Whoa, Tom and Starsift real close to each other. Tom sees RDP. RDP takes him out though. Who do we got left? We just got RDP and Starsift. RDP sees him, but misses. Here we go. RDP's chasing down Starsift, but Starsift seems to get away. They're right on top of each other here. They don't even know it. Here we go again. RDP. Will he see? No, he doesn't. They live to fight another day. And another approach here. Starsift, RDP. Starsift with the win. Congratulations, Starsift. You've won the first bot battle royale. The space station map is now fully colored and detailed with more props. Cue the montage. And that's the new space station map basically finished. I'm here in the science lab module. Looks pretty cool. Let's just go outside here and look at what it looks like outside. I think it turned out pretty good. You can see it's also got this cool Earth skybox that we're orbiting around here. But yeah, let me know what you think of the new space station map below that like button. You can now change your crosshair's color and thickness in the settings. I've always liked it when you can customize things on your HUD, and the crosshair is just one example that I've started with for now. You can now vault over obstacles, which means you can now jump and climb up ledges, which allows for some decent parkour movement. In addition to the vaulting, you can now also slide for a short distance when sprinting into a crouch. These movement additions have really changed how you can move around the maps, so it'll be interesting to get opinions on how the movement feels next playtest. That's it for this update video. Click on the playlist in the end card to watch all my other update videos. I hope you liked this update video, and I hope to see you in my next one. Until then, thanks for watching. Zippy out.